3C Part 2. The point about having an equation of regression, the line y equals ax plus b, is to use it to make predictions. And there are two kinds of prediction. There is interpolation and extrapolation. So I'll explain what they are. Supposing you wanted to know on that set of data there exactly the predicted value or price of a 6-year-old car. What do you think? Looking at the chart, 6-year-old car approximately. Look at the chart, 6-year-old car. So okay, I'm hearing 12,000. 6-year-old car, what she did was she ran up to the line and came to about 12 or 13,000. The question is what exactly? Equation here. So y, or at least price, is 35,100 minus 3940 times age. That's 35,100 minus 3940 times age. All right, so you've got a 6-year-old car. You're going to put age in there, and we'll do it on the next slide. But you put age into that equation, work out what the value of the car is for 6 years. That is when you are given the age. Interpolation, what we're doing here, because that 6 is in between the data we've got. We've got data from 1-year-old cars to 8-year-old cars. So that's interpolation. If 6 is between 1 and 8, in this case, that is interpolation. If it's outside 1 to 8, then it's extrapolation. The reason why we need to know whether it's interpolation or extrapolation is if you do an estimate or a prediction that is interpolation, you can rely on it. You can say that is a reliable prediction. If we get a number for, in a minute for the 6-year-old car, it's fairly reliable prediction. If, on the other hand, we went outside that range and we, let's say, a 9-year-old car, what do you think a 9-year-old car is going to be? 0. What do you think a 10-year-old car is going to be worth? Could a car have a negative value? Mine probably has. What would that, if it had a negative value, it means I've got to pay somebody to take it away. No, that's nonsense. Every car's got a value as long as it's running. So probably this graph wouldn't go like straight line, would it? It would probably tail off like this. Yeah? As the years go by, car goes, eventually it might even go up when it becomes an antique. So extrapolation is not, using the equation is not predictable. It's not a good prediction, I mean. Agree? Inside the range of numbers that we've been given, it's a good prediction. Outside, it's not. So when you're asked to make a prediction, decide whether it's interpolation or extrapolation, and then say whether it's going to be a good prediction or whether it's unreliable or not. Anyway, let's do that. Let's find out the actual value of this 6-year-old car. Price of a 2-year-old car. Let's do a 6-year-old car instead. So have you got that in your head, what you do? You do 35,100. Or we could do the 2-year-old, I don't mind. Minus 3950, was it? Times 3940 times x. 35,000, get your ordinary calculators out, put in 35,100 minus, and then 3940 times 6 if you're doing a 6-year-old car, 2 if you're doing a 2-year-old car. And tell me what the answer is. So x is 2 or 6, depending on what you're doing. All right, it says 11,460. Anybody got the same number? 11,460. So the 6-year-old car is 11,460. Are you happy with how I get that? Or how we get it? That is the gradient on y equals ax plus b. It's the gradient. On the equation that we got from here, it's all the same stuff. It's this one here. $13,000 car. So we're given its value. So you've got to write 13,000 equals 35,100 minus 3940 times x. So you're putting the unknown value is the age, so that stays as x, but we know what the answer is going to be, 13,000. Have you got the algebra to work out what that is? Slightly harder. You'll be asked to do either of these. On your assignment, you're given, like on here, you're given an age to work out a value and a value to work out an age. So something equals something else minus a product. No, there's no 39. No, you don't. Okay, I'll tell everybody so you know what to do. You've got to subtract that one first. So 13,000 minus, if that's a plus, you sort it on the other side and minus it. Now there isn't much algebra in this course, but this is about as much algebra as there is. When I designed this course, I did design it for the whole of Canberra about 10 or 15 years ago, no algebra, or little as possible, because that's why you're in this class rather than in methods. So 13,000, you subtract the 35,100, negative 22,100, equals minus 3940x, and from that stage you divide both sides by negative 3940. So do minus 22,100 divided by minus 3940, and you should get the age of the car that is $13,000. Negative divided by negative, you get a positive number. 5.6 years, which you've got to turn into something useful, like 5.5 years, or leave it as 5.6 if you don't know how to turn that into months, whatever you want to do. I can show you how to turn it into months if you like. 0.6 of 12 months, so 0.6 times 12, 7.2 months? 7 months. All right, well look, this is the first calculation that we've got here. Above my line is 1A and the second one is 1B, except we did a 6-year-old car instead of a 2-year-old car. What I would like you to do for the next few minutes, especially while I'm just outside for a minute, is see if you can do 2A and B, not in the same order. So 2A, the age of a 1,000-year-old car, is going to be done exactly the same as you did the age of a 13,000-year-old car. So the second equation. This one here is for A, 2A if you want to do it, and this one here is for B. See what I'm saying? Decide whether you're finding the x value or the y value and use the appropriate equation. All right. And then we'll move on to something else when you've had a chance to do that. So using the same math as here, find age of a 1,000-year-old car and the price of a 9-year-old car, which we know is approximately 0 for that one. And a 1,000-year-old car is probably 8.5 years or something. You look at the graph to see if you come up with a sensible answer, because you can guess it roughly with the graph. Same as we did here, so the same as this. 35,100 minus 3940 times 9. They're in a different order just to make it difficult for you. The only difference between the two is one is an interpolation and one is an extrapolation. These ones here are reliable predictions. The ones you're going to get with part B are not. A residual is, if you remember, is the number that's used to help find what that equation is in the first place. In this case, the residual for this value here is the difference between 6,500 and what it was actually sold for. The actual value was 6,500. That's that number here. Sorry, I'm getting it the wrong way around. So that's the number there is 6,500. There. That one there, 6,500. But what is the predicted value? Well, you'd have to put, I think we worked it out on the previous slide. We worked it out on the previous slide was 11,460. So we've got 11,460 there, and we've got 6,500 there. That prediction was, sorry, that sale was well below prediction, so that would be a negative residual. That prediction was 11,460 for a 6-year-old car, but whoever owned this car actually only sold it for 6,500, so that prediction was well below. The difference between those numbers is the residual, which is in this case is $4,960. That is the residual for that calculation. Data points above the line will have a positive value, so this is actually negative because it's below the line. And if they're on the line, of course, they'll have no residual. Now, how do we use that and why do we use it? I want to mention next. That's the calculation I've just given you, so that's 4,960. I can show that slide later if you want to see it again. That's basically what I've just done on the previous slide. If you had the residual value of every single one of those data points and plotted them, you would get a graph like this one on the right. So the graph on the right is the plot of the residuals of all the values on the left. Some of them are above the line, some of them are below the line, and some of them are pretty close to it. Why do we do that? Because if there is no clear pattern, and I think you will agree there's no clear pattern there, it's pretty random, because they're all evenly up and down, above and below the line, that confirms that that is linear and a good prediction. If there was some sort of a pattern, like a quadratic curve, then that would say that, well, if there was a quadratic curve there, which there isn't, that would imply there is actually a hidden quadratic in there. And so it would not be linear. I'll take that off again. You get that point? If the data points on the right, which is all the residuals of the points on the left, has got no pattern, then the ones on the right, then that means there is good. The assumption of a linear association between the price of a second-hand car, for some reason this sentence wasn't finished, is good. Their assumption is good. You can make it.